Welcome my dear friends in Physics of Biology Saxena. In this video, I will cover some important points of chapter light which is related with nature of light and these points are very important for the purpose of MCQ type questions. So let us start. First question, that is, what is optics? Optics is the study of light, its generation, propagation and detection and interaction with matter. Question can be asked, what is optics? And the option can be given, it is the study of light, study of heat, study of sound, etc. Then the answer should be, it is study of light. Okay. Or in this optics, we also discuss generation, how light generate, how it propagate, how we can detect, and interaction with matter. Interaction with matter with, that is how it interacts with liquid, solid, or gas. Now, question can be asked in this way: in how many parts optics divided? Optics divided into two parts. One is ray optics, and second one wave optics. Ray optics given by Newton, also known as ray theory, particle theory, or corpuscle theory. According to this theory, light is made of small particles which travel in straight line. Now, question can be asked, who gave the concept of ray theory? That is Newton. Particle theory, that is light is made of small particles. Who gave the corpuscle theory or particle theory? That is Newton. So, in this way, question can be asked in MCQ. Now for wave optics given by Huygens, also according to wave theory, that light not moves like particle, it behave like particle or then moves in a straight line. It moves just like a wave. Okay, here you can see in the diagram, it moves like a wave. That is given by Huygens. So this is the concept of ray theory and wave theory for light, over which question can be asked. Okay. Now, what is light? All of you know very well that what is light. Light is a form of energy. Okay. Now, the most important question: light particle are known as photon. Okay. Now, which type of wave is light wave? Then light is a transverse wave. Okay. And also, light is an EM wave. Okay, here you can see light is also in a category of EM wave due to its speed, because the speed of light is similar to the speed of EM wave, the wave which we use in mobile towers. Okay, for mobile communication, radar, etc. all are using EM wave, and light is also having same velocity, that is 3 into 10 raised to 8 meter per second. So light is also an EM wave, that is electromagnetic waves. So in your option, if there are four options: transverse wave, longitudinal waves, matter wave, and etc., then you have to tick mark on transverse wave. But in an option EM wave, okay, matter wave, longitudinal wave, or any extra is given, then you have to tick mark on electromagnetic. Okay, or if such type of option is given, transverse wave comma electromagnetic wave, then you have to tick mark over that one. Okay, because light is transverse wave as well EM wave also. Okay, now question can be asked, what is the angle between electric field and magnetic field? For EM wave, the angle between electric field and magnetic field, that is of 90 degree. In EM wave, electric field and magnetic field are at 90 degree to each other. Here you can see magnetic field, that is shown as blue here, and here electric field. One is on y axis and other is on z axis, and the angle, as you know, between y and z axis, that is of 90 degree. So angle made by the EM wave between electric field and magnetic field, that is of 90 degree. Now speed of light, this is also important. The speed of light in meter per second is 3 into 10 raised to 8 meter per second. In vacuum, 3 into 10 raised to 10 centimeter per second. Okay, that is for vacuum, and it is for air 2.99 into 10 raised to 8 meter per second, and for centimeter, that is 2.99 10 raised to 10 centimeter per second. Okay, here the value in air is slightly less, so we generally consider the speed of light in vacuum and air is similar, that is 3 into 10 raised to 8 meter per second. Otherwise, this one is for air. Now, light can propagate with or without medium. Means it can move in air, it can move in liquid, it can move in transparent solid and also in vacuum. Now, question can be asked: light is a transverse wave, and transverse wave needs medium. Means it transverse wave either move in solid or partially in liquid, but not in air or vacuum. Then how light can move? As I told you earlier, that light is an EM wave, and EM wave don't require a medium. Don't require medium, so it can move without medium also, that is in vacuum, or with medium also. So here is the example: light coming from sun to earth without medium, between sun and earth, but light can come from sun, that is without medium, and with medium light can travel in our atmosphere, and atmosphere having so many gases, so it can move with medium also. And why? The answer is because light is an EM wave, and EM wave can move with medium also, without medium also. What is optical medium? Okay, here the material through which light exhibits its different phenomena is called optical medium. How light interact with solid, liquid or gases. A medium which, or another definition, a medium is a substance through which light propagates or tries to do so. Means ये क्या है, वो substance through which light propagate और कोशिश करती है move करने की, propagate करने की. Now, how many we divided the optical medium in three parts? In how many parts we divided the optical medium? There are three types of optical medium: transparent, translucent, opaque. Transparent medium, okay, that allows light to pass through it. Glass and water is the example. Translucent medium, okay, that allows partially light that is pass through it, that is fog and paper. And opaque, the medium through which light rays cannot pass at all, that is metal and wood. Now, question can be asked that which one is an example of translucent medium, which one is an example of transparent medium. In this way, question can be asked, and you have to reply. Okay. Now, next, optically rarer medium and optically denser medium. Optically rare medium, a medium in which speed of light is more. Okay, that is optically rarer medium. Optically denser medium, a medium in which the speed of light is less, that is optically denser medium. Here is the example air, and here is the example water. Air is rarer than water. Now, this one is more important: optical density and mass density. Here it is written: optical density is different from mass density. A substance may be optically denser, but mass density may be low. Example: kerosene, okay, and water. When we will put few drop of kerosene oil over water, the kerosene oil start floating over the water. Why? The reason is mass density of kerosene is low compared to water, so it starts floating over the layer of water. But when we'll see the refractive index, in that case, water Ri is less than kerosene. Means kerosene oil having more optical density compared to water, because kerosene Ri is larger than water. So here it is optical dense but having less mass density. So don't think if a particular substance is optically denser, then its mass density will also high. Don't think so. Both are different things. Optical density and mass density both are different things. Now, here white light consists of how many colors? White light consists of 7 colors, and this is the relation between frequency and wavelength, that is nu is equal to C upon lambda. And also, this is our range of vision: 400 nanometer to 700 nanometer. 700 nanometer, that is for red light, and 400 nanometer for this visible blue light, okay, violet light. And if light wave have more frequency, its wavelength is less, more scattering, more energy, more bending, more value of Ri. If light wavelength has more wavelength,